Hello, today I'm going to talk about common mistakes that most people who use building, design, and analysis softwares like Protastructure, Etabs, Staadpro make when they are designing buildings using these particular softwares. This is a common mistake which lead to what we call over design, and most people will claim that these softwares are over design. But as an engineer, you're the one who should understand how the building behaves. You know, so you're the one who should be able to use these softwares properly to avoid making these particular mistakes, which will lead to over design, and your drawing may not be approved because you have over design, which will lead to costly design, which will affect the client and also your company, because you, as long as far as you want to do a safe design, you also want to make sure that your design is economical, and you want to make sure that you have a balance of this thing. So that's why most people who use this software will not often get these jobs or tenders, because they don't know are not aware of these mistakes. So let's start. One of the most common mistakes that people make is you have designed a building, and you have loaded your beams with walls which do not represent what will be and how the building will be in real life. Because as you can see here, I have these walls. I have these walls um, of I have these walls of about a dead load of about 10 kilonewtons on each beam in the first, second, and third floor. But in real life, we know that the wall is not suspended. This wall is not suspended, all right? So this wall, the way you have loaded the wall in the beam, that's not the correct way. You should not load this beam with the walls if the walls is not suspended, and especially if the wall is load bearing. What do I mean with load bearing wall? Load bearing wall, if you can check here my Excel, this is reference from a particular engineer here in Kenya. So if the wall has a crushing strength, or the rocks have a crushing strength of about 7 kilonewton per meter squared, so they are considered to be load bearing wall, right? So the crushing strength of rocks, that is Bahati Barrow pit, is 7 kilonewton per meter squared. Hence, the wall is considered to be load bearing. So if the wall is load bearing, then we are going to design a strip foundation for the wall. All right. So if you're going to design the strip foundation for the wall, as you can see in these drawings here, that means that this wall is transferring the load directly to the ground. All right. So the beams are not the ones which are holding the load of the wall, but the load is going directly to the ground. So they are being supported by this strip foundation, right? So this is how the building will behave, because the wall is load bearing. So you can see the engineer here, it's called Engineer Dua, has gone ahead and designed this strip foundation, right? Which he determined as you can see on the screen. So that is one of the most common mistakes that people will make when they are using these softwares, whether it is Etabs, whether it is Protastructure, Staadpro. You should not you should not load the walls on the beam if the wall is not suspended and if the wall is load bearing. So let's see how this will affect our design. And as you can see, the design which was approved, our columns here, you can see we are having 60 20, is it? You can see from the drawing here. So I want to check the detailing. We have 60/16 on the second floor. On the first floor, we have 8/16. All right. So let's check the design which Protastructure is giving here. So I can go to concrete design, column. So let me check column design. As you can see, we don't have any T20, but Protastructure here is giving 4T20, 4T20, actually 6T20, and you can see here we are having 8T20. Let me double click here, you can see we are having here 8T20, and if I change this diameter to 16, then definitely this column will fail. Let me go to now column analysis. So you can see the dot is way outside the interactive diagram, which means that and also both the interaction diagrams, the wall is outside, implying that the column is failing in both tension and compression, right? So you can see this is clearly over design. This is over design. Now this dot is inside this interactive diagram. Now it is passing in tension and compression. All right. So you can see how it has affected our columns. So let's see how it will affect our beams. I'll go to concrete design, beam, story beam. Then you can see most of my beams have failed here. And for those which have passed, if I can check this beam here. All right. So these beams which are failing, the beam here you can see it is failing right here. It is failing at these support rebar. Let me check this one. Let me try to do design pattern 1. So you can see we are getting T20s and a lot of T20s. We are getting an over design in beam also. So this one, most of these beams are demanding that we use T20. So here, for example, if I can increase that and increase this one to T20, but it is failing here. Let me increase that to T20, 25, 32. So you can see the effect of that error, that mistake in modeling, where you loaded your beams with the walls, but in real in the ground the wall is not actually suspended. So here it's like this wall is suspended. It's like it is being supported by those beam, and it's like we're having uh, maybe a parking down here, which is not correct. So this wall is going straight to the ground, and that's why we are having masons and their tools, including the pram board, to make sure that that wall is not tilted even a bit. That wall is at 90 degrees. It is transferring its load directly through the gravity straight to the strip foundation. So that is a very common mistake that engineers make. So if I can go to let me go to I want to check so many members are failing, including these. Let me go to that, and then let's go to plan view, including these footings. Even the footings will be over designed. You'll be having very big footing with T20s, which we know is not what was actually done on site. So it's like you are suggesting that this was approved by mistake. As you can see, the footings here are very just 15, 12. How many types of footings? This one is 2100 by 2100, 1800 by 1800, 2400 by 2400, and just using T16 and T12. T16 and T12. There is no T20 in these footings, but here, if I can let me select all the footings, delete pads and pile bases. Okay, let me delete pile and pad bases, delete, and check columns. Then I will select everything. Let me delete even these ones, delete, and check column. Okay, so I'll select everything, then insert pad bases. You will notice over design even in our pad bases. So I want us to go ahead and delete those wall loads in our beams, assuming that the wall load is supporting itself. The wall is supporting itself, and now the building is just supporting the slab and the slab self weight, its own self weight of the frame, that is the beams and the columns, and also the live load from maybe slab and extra dead load from slab. So let's see how our design will look, or what we'll get in terms of our design. So this one is done halfway. Don't worry. So this design was done halfway. Then the rest of the half you use the same design. All right. So you design up to here. Now you can mirror this design to the other side. So don't worry. That's how sometimes the design is done, and to your surprise, you realize designing halfway will make you more faster and more accurate. So you can just design halfway instead of doing the design of the entire building, which has symmetrical parts. So we are having these A4 with the 2400 by 25 by 400, the depth. So let's see the property. Okay, calculate. You can see T16 is failing. If T16 is failing in shear, so this is failing. It's demanding us to use T20 to increase or even maybe reduce these maybe to about 75. Let's see. Now it is passing 75. You can see the design which is passing. It is T16 at a spacing of 75, and this one was T16 at a spacing of 200. So clearly this is an over design. Okay, that is an over design. So let's assume that now these our beams do not have any wall load. So I will go back to the 3D view. Let me select all my beams in this is second story. Holding shift. So this is Protastructure. You do the same thing when you're using Etabs and any other software. So this apply to all the softwares that you are using. So let me go to delete beam overload. Yes. The following analysis will be invalidated. Again, I will go now to. So I wanted us to look at the visual interrogation. We have seen so many members were failing. So I'll go to that flow. Delete beam overload. Then I'll go to the sixth floor. That is the sixth story. That is that floor. Then again, I will do the same thing. Delete beam overload. Okay. Now let's repeat the analysis, building analysis. Okay. So analysis. Perform eigenvalue. Perform column beam. Let's select bar. And then start. So I'm selecting all bar to see if 8016 will be sufficient for a column as done in this drawing, and if our beams will pass using just the normal T16. And you'll find if you go to the site, these beams, they will even use T12 most of the time, T12. And if you're consulting, if you're using this software to design, then you submit your drawing, then there is complaint, then you consult, they tell you just you do this, just put 2 T16, 2 T12 on top and 2 T16, based on this experience engineer, based on the span, but they're not telling you why why that should be sufficient. It's because you yourself, you don't understand how this building will behave, and that these walls will support itself as long as it's not suspended, and the rocks or the blocks they are using are load bearing walls. Okay, then I will close. Then I can go to concrete column. Now you can see they are passing Okay, I want to now this one is column 1. Maybe use T16 and add another T16 here. Okay, quantity just 1 intermediate. Okay, T16. Okay, so let's go to column analysis. You can see this one has passed in both, the column is passing in both tension and compression because these dots are within the interaction diagram, right? They are within this interaction diagram. So 8016 is sufficient as represented in this drawing here. So we don't need to use T20, okay? And if I can go maybe to settings, let me go to settings, column settings, steel bar, longitudinal. I will use a minimum, a maximum of 16. Okay. Then okay. Then do column design again. I will do analysis. I want to do FA analysis. I'll do analysis, building analysis. Analysis, perform column beam, check, start. So what I'm trying to say is that this is a very common mistake, and don't load a beam a beam with wall load if the wall is not suspended most of the time, and you can use your judgment to know which wall is suspended. Maybe there's an opening down or there's a gate, if you want to be more accurate. But sometimes some engineers will just, if they're using this software, they just ignore totally that all walls are transferring the load directly to the ground or to the strip foundation. So the beams are just like this. So let me check the columns again. Now you can see T16 is passing in all apart from maybe here. I don't know where the T12 cannot pass in this column, so just increase it to T16. Again T16. Now check the interaction diagram, still outside, so means we have to use again intermediate. You can use T16, so interaction diagram, so they are now within. Okay, then okay. Or we can just do again design. and close. All my columns have passed. Here I can just do interactive design, then okay. Here again, 1 to 16, okay. Analysis, you just check, make sure these dots are within this interaction diagram. They are indicating that the column is neither failing in compression or tension. Then your column has passed. So all column passed the design check. Do the same thing for our beams. Our beams is definitely just T16, not T20 anywhere. But if you do the other way, you will definitely get so many T20s. And your drawing will not be approved. So this one you can see 3T16, and at the supports, and just do select all, calculate. Then you can go editing one by one. You realize that you can easily pass this beam, or most of them have passed. If you can check the utilization ratio, it is less than 1, which indicates that these beams have passed. If the utilization ratio is more than 1, then that one indicates failure. So definitely these beams have passed, all of them. I hope this video was helpful. If you like this video, please consider to subscribe to my YouTube channel. And to all those who have subscribed, I would like to say thank you for your support. And that is what encourages me to create more content, and we can be able to grow as structural engineers. So thanks. I will see you in another video.